In this practical, we are about to perform firmware update, particularly application firmware update in ESP32 using HTTP OTA. OTA means over the air method. Now in this practical, we are about to use two third-party services. First is Blynk application for triggering the OTA event or for triggering the firmware update process, and GitHub for storing the firmware.binary file. Now in this practical, make sure the firmware that you are about to load inside ESP32 is not more than the 1.3 MB of size, because we are using ESP32 4 MB flash memory version. So it has some limitation because it has a limited space to store the firmware, right? So make sure you don't exceed this 1.3 MB of limit. Now let us discuss the basic things. What is firmware and what do you mean by firmware update? So firmware is nothing but a specialized type of software, or we can call it as a piece of code that is stored within a hardware devices, for example ESP32 or Raspberry Pi or any other controller, router, smart TVs, or even your mobile phone, that controls how the device should operate. First of all, let us discuss about what do you mean by firmware update. So firmware update is nothing but replacing the existing firmware or the old firmware with a new version. Now that will bring some of the advantages. So due to this firmware update, we have some advantages like we can fix the bugs, we can add a new feature to the system, we can change the application functionality, then we can improve the overall performance. For example, if you want to optimize the code, if you want to optimize the overall system performance, right? If you want to execute the code at a faster rate, etc., you can do so with the help of firmware update. You can also patch the security issues. So by updating the firmware, these are the advantages we can get. So we are performing this firmware update process. Now let us discuss the firmware update, particularly in the case of ESP32. So in ESP32, for example, you want to blink an LED, simple code. So what you have to do? So you have to write one application code of blinking the LED. Then you are compiling it. So in Arduino IDE, we are generally writing the code for it. Then you have to compile the code so that the compiler will generate the .bin file, right? So this is called application firmware. Okay. And finally, you place that code inside ESP32. So this is called application firmware update. Another firmware is that it is called system firmware. So this system firmware is nothing but once you, for example, if you buy this ESP32 board, right? So there is a pre-installed binary file which is there inside this flash memory of ESP32. Okay, written by the manufacturer. So that is called system firmware. For example, if you want to change the system firmware, then you have to go to the official website like Express ESP32 and you have to download the system firmware and you can install the update inside ESP32. But in this practical, we are not about to perform this system firmware update mechanism, right? Instead of that, we are going to update application firmware inside ESP32. So once you write the code, let's say you have generated the bin file, then typically what we are doing, so we are going to use one USB cable and Arduino IDE or platform IO software to install or to burn that file inside ESP32, right? But in this practical, we are going to use over the air or OTA method. So with the help of this method, you can update the firmware remotely using Wi-Fi without even touching the board physically. So that's the advantage we can get by using this OTA method. Now there are basically three types of OTA using which you can update the firmware. First is Arduino IDE OTA. So this is very basic and good for the development purpose. So in this approach, what you are doing, you are going to write one OTA triggerable code inside ESP32 and burn that code inside ESP32 with the help of USB cable. So first time you have to use USB cable code, then you have to burn that code in ESP32 with the help of Arduino IDE, and later on all the future triggering of firmware will be performed over the air. But there is a limitation of this approach. What is the limitation? You have to be there on the same network on which ESP32 has been connected. So you cannot perform remote update with the help of these approach. So that's the limitation, right? You have to be locally present within the ESP32 network, right? Then and only then this update is possible. Second and most practical and viable option is HTTP OTA method. So in this approach, what you are doing, you are going to write firmware. You are going to save firmware binary file onto server like GitHub or Google Drive. And with the help of this approach, you are going to trigger that firmware update and load the code inside ESP32. So it is very much practical. With the help of this, you can also automate the firmware update process. And with this method, you can manage many devices, many ESP32. For example, if you want to update the firmware, it is possible with the help of this approach. Third and last approach is OTA via web browser. Let me explain you this concept. For example, you are running one ESP32 server. This is ESP32 and you are running one ESP32 server. Now you are there anywhere in the world, right? And with the help of web browser, you are accessing the IP address of this ESP32 and the web page will open in this web browser. It is same like you are opening any website. Now, if you trigger, let's say with the help of this button or anything, you are going to trigger the event and finally you can update firmware inside this ESP32. But there are certain limitations. First, it is not secure. Second, it is not reliable. Okay. Imagine in between when you are updating the firmware and anything odd happen and update will stop, then there is no fail-safe mechanism. Okay. So for that and some limitations, we are going to perform all the OTA updates with the help of this HTTP second method. Okay. Now, what are the advantages of OTA firmware? So imagine again, you have deployed hundreds of ESP32 devices spread across different locations, possibly miles away from you. And it is not possible you go and check every ESP32 and manually install the update. For that, it is the best practical solution to use OTA firmware update. So you can stay remotely, install firmware update directly into the ESP32 flash memory without needing the physical access. So these are the benefits of OTA for ESP32. So first of all, no need for physical USB connection. Post the update from anywhere over the internet. It fixes bugs, add features, or even change the behavior anytime. So this is a smart and scalable way to manage large number of ESP32 devices effectively. Now let us talk about the differences between system firmware versus application firmware. So first feature is purpose. So what is the purpose of system level firmware update? So the main purpose is for boot and manage flash memory. We are going to use system level firmware, and to run our main application like LED blinking or reading some sensor data, etc. We are going to use application level firmware. Who writes it? So chip vendor or SDK provider writes the system level firmware and the developer will write the application level firmware. Then the update frequency is very rare in system level firmware, whereas application level firmware needs to be updated frequently. Examples like bootloader or partition table are the examples of system level firmware, whereas sensor code, LED blinking code, or temperature sensor reading, etc. are the application level firmware example. OTA impact. So OTA will not impact system level firmware because the system level firmware can be done with the help of manually writing the code from the command prompt, right? Whereas this OTA will definitely impact the application level firmware. So we can change the application by writing the OTA update. Okay. If you talk about real-time example in mobile phone, like if you want to change the OS version, for example, you are using right now Android 13 and you want to update it to Android 14. So it is called system level firmware update. Whereas if you change, let's say if you update the WhatsApp or Instagram or LinkedIn application, it is called application level firmware. So hope you get enough idea about these two things. Now, one thing you have to note down that in this practical, we are going to perform ESP32 application level firmware using HTTP OTA method. But you can also perform system level firmware. Okay, if you want to change the system level firmware, then what you need to do, first of all, you have to install the file from the official website. You have to store that file into your PC and laptop, And by standard CMD command, you can store and flash the system firmware inside ESP32. So let's have a quicker look. This is not our area of interest in this practical, but it is optional for you. If you want to try, you can by following this step. So briefly, I'm going to tell you what you need to do. So suppose you want to take the backup. You have purchased ESP32 and you want to take the system firmware backup, or you want to reinstall that backup that you have taken. If you want to reinstall the same backup, or if you want to place a new system firmware, then these are the steps that you need to follow. So first of all, you have to install Python software. Then you have to install esptool.py. So this is the main tool used to flash or backup ESP32 system firmware, right? So run this in your terminal or command prompt. You have to run this command pip install esp tool, right? If you want to check whether it is installed or not, then you have to run this python m esp tool version command, right? Then in the third step, you have to connect ESP32 to USB, and you can see on which on which COM port ESP32 is connected, right? Now, if you want to back up the entire ESP32 flash memory, then you have to run this command. It is written like this, right? And finally, after the backup is completed, you will have ESP32 underscore backup underscore full, or any file link that you have written inside here in the same working directory. Okay, so this is how you can take the flash backup, entire flash backup of ESP32. If you want to reinstall this backup, then you have to run this code. You have to run this code inside CMD. If you don't want to reinstall backup and if you want to perform a new system firmware update, right? Then what you need to do, so first of all, you have to go to official ESP32 website. So here you have to write ESP32 firmware, right? Then you can see, you can check various firmwares are there. So first one is the latest one. So first of all, you have to download it. So you can see download is already in progress. 25 MB of file is there, right? So you have to store this file, okay, inside the current working directory in which right now you are working, okay? And finally, you have to run this code to install that binary file, okay? So by following this step, you can install system firmware inside your ESP32. Now let us understand the ESP32 program execution flow with flash memory of 4 MB of size. So on power on or reset, first of all, ROM bootloader. So this ROM is there inside ESP32 in which manufacturer has already written hard-coded logic, right? So first of all, control is transferred to this ROM bootloader. Then it will transfer the control to the flash memory. So it will go to the location 1000 address in which secondary bootloader is there. Now, this bootloader reads the partition table located at location 8000. Now, this partition table is nothing but the blueprint of your memory. Okay, it will tell the ESP32 exactly where is the ROM bootloader, where is the non-volatile storage, right? Then where is the OTA slots, etc. are available inside this partition table. Then it will initialize the non-volatile storage at 9000 location. So in this storage, you can store let's say Wi-Fi credential or password or any other information which you want to retain even after the power has been lost, right? So it will initialize this NVS later on. Then it will check the OTA data at location F000, right? Now we have two OTA partition, OTA 0 and OTA 1 at these respective addresses. Now which OTA application to use, that will be decided by this section which provides the OTA related data, and it will tell the ESP32 whether you have to go for this OTA or OTA 1. Then now in your program, if you are going to use a file system, for example, if you have web pages or if you have configuration files or log files that you can store at this location 3C0000. So it will also support the storing of the file system. Okay, and finally, it will execute the application from the selected OTA slot. Either it would be OTA 0 or OTA 1 based on the OTA data available over here. And finally, it will start executing the code, and it will execute these two functions setup and loop, which you have already written in your Arduino code, right? So this is how your flash memory will initialize and finally run your application code, right? Now, this is the Blynk template that I'm about to show you. So in this Blynk template, we are about to take one LED widget and LED blink count widget, right? Now let me explain you by drawing ESP32. So ESP32 is there, right? We are going to use on-chip LED on ESP32, which is connected on GPIO2. So as this LED is blinking, same blink should be reflected on this LED widget. Okay, and this widget will show how many times this LED has blinked. Okay, now once I trigger, this is the push button that I have taken. So once I press this push button, the firmware update process has been started, will be started, right? For example, if you have, so right now we have taken GitHub. So on that GitHub, we have .bin file already saved. .bin file already saved, right? So once you press this button, this bin file is loaded inside ESP32. First of all, it will be downloaded and then it will be placed inside ESP32. And once this process has finished, the firmware update successful message will come. You can see that on your Blynk application, right? Now, once ESP32 is updated with the firmware, it will start from the last LED blink count. For example, last LED blink count is 117. So after the reboot process, it will start from 117 onwards. So this is how you can retain the critical application data during the update process even, right? So if the power goes off or if you are doing the firmware update process, at that time, this critical data is stored inside non-volatile NVS section. Okay, when again ESP32 will be booted, it will take this data and start the execution from this data onwards. So this is very useful approach. Let's say you are working on project in which data is very critical. So before you start updating the firmware, make sure that you have taken the sensor or any other input output or any other flag data inside non-volatile storage. You have stored it in NVS section, and later on you have to push for the update. So whenever again it will restart again, that data will be again read from this NVS section of this memory, and program execution will be started from that final state onwards, right? So hope you understand about this Blynk template as well. Now let us understand the ESP32 code for this project. So first of all, you have to insert this three Blynk credential: Blynk template ID, Blynk template name, and Blynk authorization token. With the help of these three credentials, ESP32 will connect with Blynk server. So I will show you how you can find these three credentials later on. Then first library you have to include is Wi-Fi library, through which ESP32 is connected with the Wi-Fi. Then HTTP client.h library you have to include to fetch the firmware via HTTP protocol. Then we have to include Blynk simple ESP32.h file. So with the help of this, ESP32 will connect with the Blynk server. Then update.h library. So this will be useful for OTA firmware update. And finally, we need to include preferences.h library. Now, this library is needed because at the time of ESP32 booting process and at the time of firmware update process, we need to retain the LED blinking count into the non-volatile area of the memory. And for that, we have to use this preference.h library. It will store the blink count in the NVS section of the flash, right? Then OTA URL. So this is the GitHub URL on which this file you can see firmware.binary file I'm going to load from this GitHub. And this is the URL for the same. Again, I will show you how you can find this URL later on. LED pin is connected to GPIO2. Then SSID and password. Here you have to replace your Wi-Fi credential, SSID and password, through which ESP32 will connect to the internet. Then we have to create one instance, timer instance. It will be used to schedule the task like LED blinking. Then preferences preps. So it is used for non-volatile storage. Like in our case, we are going to store the LED blinking count. Okay. Then int blink counter is equal to 0. So we have taken one integer variable called blink counter and initialize this variable with 0. Then update in progress flag. We have taken one boolean flag, update in progress, and initialize it with 0. So whenever update is in progress, we are going to make this flag as a 1. So this will be useful to prevent any repetitive OTA trigger. Suppose you have pressed the button for firmware update, and again before the update has been finished, and if you re-trigger that push button, then it will prevent the repetitive OTA trigger, right? So that's why we have taken this flag. Now, once you press the push button on the Blynk application, so it will trigger this V2. It will enable the V2 virtual pin. So this function will be automatically called Blynk write V2, right? Now, it will check if the V2 button is pressed, and it will again check if the update is not in progress. If the update is not in progress, then what it will do? It will first make the update in progress flag to 1. That will indicate the update is about to start. Then we have to display the message firmware updating ... on V3 virtual pin of Blynk. Same message we are also displaying in the Arduino IDE serial monitor. Now we have to call the perform OTA function. We will understand the functionality of this function later on. Ending of this Blynk write function, right? Now let us understand the Blynk LED function. So this function, Blynk LED function, whenever it is called, it will toggle LED every time it is called, right? Now let us understand the definition of this function. Static bool LED state equal to false. So we have taken one variable LED state and initialize this variable with 0. Then LED state equal to not LED state. LED state is equal to not LED state. So this will toggle the LED state. Right now it is false, it will become 1. Again, if you call this Blynk LED function, again it will be 0, 1, 0, 1 like that, right? So it will be toggled every time it is called. Now we are going to reflect the same LED state to the pin number 2 so that the actual physical LED on GPIO 2 will be turned on and off based on the LED state, whether it is 1 or 0, right? Then we are going to write the same LED state on V0 virtual pin on LED Blynk on Blynk application. If it is 1, then V0 is 1. If it is 0, then the V0 is 0. Okay, so it will check LED state. It is 1, then V0 is 1. If LED state is 0, the V0 is 0. So this will reflect the same physical LED state on V0 virtual pin of Blynk application, right? Now we need to count LED state only. The LED will turn from 0 to 1, not from 1 to 0. So we are just counting LED on state. Okay, we are not going to count 1 to 0 state, but we are going to count 0 to 1 state. So if LED state is 1, it will enter into this loop. Now we have to increment the Blynk counter variable by 1. Now remember, every time we are going to increment this Blynk counter with 1, we have to store this Blynk counter with this pref.begin, prefs.putInt, and prefs.end. So these three functions will store Blynk counter state, okay, inside non-volatile storage of the flash memory, right? So this will be needed whenever if the power goes off, or if ESP32 is rebooting, or if you are doing a firmware update task. At that time, the last Blynk count will be stored inside NVS, right? Then we are going to display Blynk count on V1 virtual pin as well. Then ending of this Blynk LED function. Now let us understand the perform OTA task. Okay, so once you press the button, the V2 will call this function. Now let us understand this function. HTTP client, HTTP. So it will start the HTTP client. Now this function will redirect the HTTP request. For example, right now we are using GitHub. Okay, and we have stored the binary file on the GitHub. So sometimes what happen, HTTP 302 error will come. So that is called HTTP redirect. So in order to handle that redirect error, we have to write this function, right? Then HTTP begin OTA URL. So we have already provided OTA URL. So from that URL, it will begin download the .binary file. Then it will check whether the HTTP connection is okay, and then it will start initializing the update process. Now let us understand what is there inside this if loop. So first of all, it will start streaming the firmware data directly. By writing this function, it will start streaming the firmware data directly from the GitHub. Now, if the update is ended or if the update is finished, then we have to write, or you can display OTA success rebooting message onto the serial monitor of Arduino IDE. Same message you can, if you want, you can also display the same message on virtual pin V3. Then we have to, before, now it's a time to restart ESP32, but before we restart ESP32, it is the best approach is to store the final blink count. So by writing again these three function, we are going to store the blink count inside ESP32 non-volatile memory. Delay of 3 seconds. Then we are going to write on virtual V3 firmware update successful. Delay of 5 seconds. And finally, we are going to restart the ESP32 again. Else, it will print OTA failed at the final stage. Finally, ending of the main if loop. Now, if that fails, then it will print HTTP OTA failed and it will return the code, HTTP code, okay, like 302 or 202, like that, okay. Finally, release the HTTP client, and before we end this loop, end this function, we have to reset update in progress flag to 0 for the next round, right? Ending of the OTA function. Now, let us understand the setup. So first of all, we have to start the serial communication with this baud rate 115200. You can also take 9600 baud rate over here. Then LED pin mode we have defined as an output pin. Wi-Fi will be started with the help of this SSID and password. So ESP32 will connect to the Wi-Fi with this SSID and password. Then Blynk will be configured by using this authorization token, which we have already provided in the starting of this code. Now we have to load the saved Blynk count. See, once the ESP32 is rebooted after the successful firmware update, this setup function will be executed first. Now what we need to do, we have to restore the final LED count inside ESP32 flash memory. So, and for doing that, we have to write this three function, pref.begin, blink counter is equal to prefs.getInt. So previously we have used putInt, right? PutInt is used to store the blink count inside flash. If you want to restore the data from the flash memory, you have to use this getInt function, right? So the final blink count will be restored and ESP32 will be started from that count onwards, right? Timer.sort set interval 2000L blink LED. So this function will call LED blink function or blink LED function every 2 seconds. If you write 1000, it will call this LED blink function, which we have already discussed, every 1 second. And what this function will do, it will toggle the LED for the given period of time. Okay. And finally, end of this setup loop. Now let us understand the loop function. So here we have taken two variables, last Wi-Fi check and last blink check. Now and initialize it with 0. So the function of these two variables is to check Wi-Fi connectivity every 5 seconds and blink connectivity for every 3 seconds. So let us understand this code. So if the Wi-Fi is not connected and the last check time is greater than the 5000 millisecond, it will print the message reconnecting to Wi-Fi in the Arduino serial monitor. It will start connecting with Wi-Fi again with SSID and password that we have already provided, and it will update this variable last Wi-Fi check with the current time. Now if the Wi-Fi is connected, okay, then it will check if the blink is not connected, and if the last blink check time is greater than 3 seconds, it will enter inside the if loop. Again, we have to display reconnecting to blink so that we can check the status right now, what is going on. Then blink.connect, it will start connecting with blink server, and we have to update the current time to the, once it is connected to the blink, we have to catch the current time into the last blink check variable. Else, if blink is connected, then we need to make sure that the connection is remain forever. And in order to do so, if the blink is connected, then we have to write this function blink.run that will ensure the blink is stay connected forever. Finally, ending of this if loop, timer.run. Now this will check if any schedule timer functions need to be executed. So already we have used the timer function, and in order to check that schedule timer function, or in order to run that timer function on predefined time, this function you have to run, right? Ending of the loop function, finally ending of the loop function. So hope you are getting the idea about this code. Now let us understand how you can do the Blynk setup. So here I'm going to explain you how you can design this kind of interface on Blynk application. So here you can see LED is there, LED blink count is there, firmware update button is there, so that whenever I am pressing this button, the firmware update process will be started. And finally, you can see here firmware status. So if the update is in progress, it will show the update in progress. If the update has been completed, it will show firmware successfully installed, right? So let me quickly explain you how you can design this kind of template on Blynk. So first of all, on the top side, you can see setting icon is there. Just press that setting icon and you will enter into the developer zone. Now in that developer zone, here you can see plus sign. So here are the templates which I have already made. Okay, and the firmware update template also I have made, but I'm just going to show you how you can create one for yourself. So just press on this plus icon. Here you can give any name. Let's say I'm going to give name as a test, continue. Here you can choose any tile design. Let's say I'm choosing this tile design. It's an optional and it is of your choice. Now you can either press on this grid bar, or you can press on this plus icon. Okay, and widget box is open for you. Now first of all, I'm going to take one LED. So by long pressing that LED, if you don't want to if you want to discard any widgets, just long press it and you can discard like this from here. Again go to plus LED option. Now long pressing and releasing, that means you can now customize it as per your requirement, right? Now you have to click on it. Now here you have to give the data stream. Okay, so for the button we have taken in our code example, we have taken as a V0. So here you have to create a virtual pin. Already V0 has been selected. You can see V0, V1, all the things are there. All the virtual pins are there. So I have selected V0. Now integer you have to select. Minimum value is 0 and maximum value, as it's an LED. So that maximum value is 1. Okay, so 0 and 1. Unit is none. Okay, enable history. That's it. This is the setting for LED, and here you can see design. So here you can give title name as an LED, and alignment you can set from here. Let's say I'm centrally aligned it. Okay, so that's it. This is the setting for LED. Same way, I'm going to take one widget for displaying how many times the LED is turned on and turn off. So let us select this value display widget. Okay, long press it and you can adjust it as per your requirement. Now again press on it, choose the data stream. So here I have taken V1. Here I'm going to take V1 as per the code. So what is the maximum value? So maximum value is, let's say I'm taking as a 65,000. Randomly I'm taking this value, right? So 65,000 is the maximum value for integer, let's say. Okay, so that's it. Click OK. Design again, if you want, you can write anything you want, like this is LED blink count. So I'm just writing blink count. Okay, and you can centrally align it if you want. Here font size you can adjust. Okay, now that's it for blink count. Now I have to take one push button. Okay, this push button, if I press, then what happens? The update, firmware update process should be started, right? So again click on it to configure it. Now here you can see switch, page, push. So here I'm going to take push button. So whenever you press it, it will give 1. Okay, again choose data stream. So V0 and V1 has already been occupied. Let's take as a V3 as a virtual pin for my button, V2 as a virtual pin for my button. Okay, integer is 0 and maximum value is 1 because button is there. So 0 and 1 digital property we have to assign.
click OK. Here you can see again design, you can write it firmware update, let's say. Okay, centrally aligned, medium, large, you can choose it. Here you can also choose the color. Let's say I'm choosing this color. Okay, now one more item, I have to take one more widget, and that is again value display. Okay, now this value display is for displaying the status, whether the update has finished or it is still in progress, right? So again click on it. Here we have to give the data stream, so v0, v1, v2. Now v3 I am going to assign. Okay, and this is the string variable. Okay, so choose string variable because we are going to display the string on this widget. Okay, so that's it for this. Press OK. Design update status, you can write update status or firmware update status, you can write here. Okay, centrally aligned it. Here medium, large, you can adjust by yourself. Let's say color I am choosing as a red one. Okay, okay, now this is it. So I have already created a widget called test. Now you have to go to press back button and you will be in a developer zone, right? Here you can see 4 templates are there, and right now I have created this test template. So first of all you have to close this developer zone option, so close it. Now on the top side you can see plus icon is there, right? So go to that plus icon and we have to add this template into the device, right? So add a new device. So last option is manually from the template, and just now we have created a template called test. So let's select the test option and create. Okay, and the test device has been created. Okay, again if you go to backside, if you press this setting icon, here are the template. Again close this developer zone. Okay, and you can see the test icon is there. Okay, test device is there. Okay, now I'm going to explain you how you can take the Blynk credential like Blynk template ID, Blynk username, Blynk authorization token, etc. So here there is a limitation in this Blynk application. So I'm going to show you how you can take those 3 credential in order to use it inside your course.
Let me go to the Blynk official website and I have to log in with my same login credential. So already I have logged in. So my Blynk console is open. And here you can see test template is there, which, test device is there, which I have just created. Okay. So first of all, go to developer zone. So here I am going to talk about one little bit thing that I want to explain you. Go to this test device and here you can see data stream. So click on this data stream and the last in that is v3. So first of all, go to edit. Okay, and string v3 you can select from here. See, some of the options are available in web version only. Okay, web version provide you some more features. Okay, and this feature is not available in Blynk application. Okay, now here you can see advanced option is there. Now just you have to enable the first one, invalidate in 0 second, then set nothing, right? So what happened whenever I see the message that a firmware update has been finished, at that time just I am going to if I refresh the screen, then what happens? The message will be disappear. Okay, so for that you have to choose this option, invalidate in 0 second. Just save it. Now you have to go to this device option. Now in that device you can see test option is there. Go to that test option. Now here you can see one setting icon, developer tool option is there. Go to that developer tool option. Okay. Bottom side, you can see 3 credentials are there, template ID, template name, and authorization token. Now, click to copy the code. So I have just copied this 3 login credential, and in the program, you can see template ID, template name, and authorization token is there. So you have to replace your ID, your template name, and your token, okay, as per your developer tool, as per this. Okay. Now, this has been finished. Now, what is the next step? Just we have to create or we have to save one file into the GitHub. Instead of GitHub, you can also go for Google Drive. So let me show you how you can save the firmware file from which once you press the button, it will take the firmware file from this GitHub option. Okay, so go to this GitHub, login. First of all, you have to log in, and here you can see create repository, right? So I'm going to create one repository. You have to give one name. Let's say I'm going to give the same name. It is available. Okay, description is optional, and here you have to choose public. Otherwise, this will not work. Okay. Actually, what we are doing right now, we are just placing one dummy firmware file, dummy.bin binary file. Okay, I am going to show you and you will understand as we proceed. Okay, here add a readme file. Again, it's an optional for you. If you want to write project information, you can write it in this file. Okay, create repository. Now you can see repository is being created. Now it has been created. Okay. Now this is the main repository, main branch. Okay. Now here I have to add one file. Let's add one dummy binary file. Okay, I will explain you why we are doing so. So first of all, you have to create one dummy file. Okay, on the desktop. Let's say I'm going to create one dummy file. So go to new option, text document, and here you have to write firmware.bin. So this is my dummy binary file. Okay. Yes. So this is 0 KB dummy binary file. Okay. Now double click on it and you can see now the file has been uploaded. Just you have to commit the changes. So press this commit changes option and the file has been finally uploaded on this GitHub, right? Now I want a link. Okay, you have to paste the link of your firmware file. This is the link. Okay, this is the link in my case. In your case, the link is different. But make sure this link will not be changed in all the future firmware updates. So I'm going to show you how you can do that. Right. So first of all, you have to find the link for this firmware file. So press on this firmware.bin file, and you can see row option is there. Right. So if you just make sure if you press this row, then automatically this file should be downloaded. Instead of just opening the file, this file should started downloading automatically. Okay, so let's check it whether it is automatically downloading or not. So right now it is opening. Okay, so this should not happen. Okay, now let's check whether this firmware.binary file has been automatically will start downloading automatically or not. Okay, so let's press it, and you can see row option is there. Press this row option and you can see the file has been downloaded. Sometimes it may happen if you press this row button, then instead of automatically downloading the file, it will open this file in a new tab like this. Okay, so don't worry because this is an empty file. So sometimes it may happen then if you press this row button, then instead of downloading the file, it will open up the file. Okay, but whenever we update this file with the genuine firmware.binary file, the update should start, or the download should start automatically. Now I want the link. Okay, that's why we have done all these tasks. So just right click on this row and you have to select copy link address. Okay, just check this link in a separate window, press enter, and you can see that downloading has finished. Okay, now you have to use this file, you have to use this link over here, right? So you have to paste that link over here. Now these URLs should not be changed because only for the first time we are going to load this code via USB cable and Arduino IDE. Okay, for the first time, and on all the future coming updates should be done automatically. And for that, make sure this link will not change. We will see that how you can do that. Right now, this is okay. Now this has been finished and our code is now ready. Okay, we have updated two things, this Blynk template and this GitHub link. Now next task, open Arduino IDE. Now I'm going to upload the code which I have just selected to you. Only thing that you have to keep in mind, you have to change your Blynk credential, your Wi-Fi credential, and the GitHub link. Okay. After changing that, you can now upload this code inside ESP32. But remember, we are going to upload this code via USB cable only for the first time. And all the future coming updates we can perform with the help of OTA by sitting anywhere in the world with the help of Blynk application. So let us upload this code. So I'm pressing the upload button over here. It will take some time because we have used many libraries. Okay. And initially in this code, I have taken 2-second delay. Okay, 2-second delay. And in the future firmware update, I'm going to change this LED blinking delay. Okay, over from here. We will see that. First of all, let me upload this code inside ESP32. It is now being compiled. Once the code upload has been finished, you can observe the LED blinking on the ESP32 physical board. So right now the compilation is still going on. Okay, now the uploading process has been started. Now you can see the code is uploaded and you can see the LED blinking. LED is blinking at the rate of 2-second delay. Okay, you can observe on ESP32 board. Now I want to observe the same blinking of LED on my Blynk application. So let us go to paste device. Now, right now you can see the LED, this Blynk application is not connected with my ESP32. So first of all, I'm opening this serial monitor on Arduino, and first of all I have to connect. I have to turn on my Wi-Fi. So I'm turning on the hotspot so that ESP32 is connected to the Wi-Fi. So you can see reconnecting Blynk. So one device has been connected. So now ESP32 has been connected. Just I'm refreshing it. Okay, so this is the test. I have to take this one, firmware update. Okay, I forgot that. Okay, and you can see the LED blinking is showing. So you can see same thing you can also observe on Blynk application. So at the same time, you can also see the LED blinking count 23, 24, etc. Right? Now I want to change the blink count. So what I need to do, I have to change the 2000 to 500 for 500 millisecond or 0.5 second. Now you have to go to this sketch option and you can see here export compiled binary option is there. Just place that option. It will take some time to compile this code. Okay. Now we are not going to use USB cable. Okay. Or physically for uploading the code physically. Okay. All this thing now we are about to do OTA via OTA by sitting anywhere in the world. Okay. But for that we need to have binary firmware file. And you can get that file from the option shown from the sketch, and here you can find the option. Okay, so it will take some time. Okay, so now the compilation has been finished. Now I want that compiled binary file. So where should I get it? So you can see in the file option, if you go to open, then you can find the sketch path of your sketch, right? So it is there in document Arduino. So go to this, your current project, that is OTA firmware update. And here you can see build option is there. Go to that build option, go to this option. Okay. Now I have to go to this option. So right now I'm closing it and manually I'm going to reach in that location, reach to that location, right? Okay. So let's open the documents and then Arduino, and then you have to select this OTA firmware update build, and you can see right now this file has just been created, OTA firmware update, the sketch name .ino.binary. Okay, time and date you can match. Okay, now you have to replace this file name with firmware.bin file, because in the code already we have taken this link with the file name called firmware.bin. So make sure this name should be rewritten with the name called firmware.bin. Okay. Now I'm going to upload this file on GitHub. So let's open the GitHub. And we have already uploaded one dummy file just to get link address. Okay. Now go to this add file, and here you have to upload the the file which we have created just now. So upload file, press on this option, choose your file, and you have to go to document Arduino where the sketch is there. You have to go to this one, build, and you can see our file is here, right? So this is the file for 0.5 second LED blinking code, right? So click on this file. Sorry. Okay. Again, I'm going to firmware.binary. I have to change this file. Okay, so from here you can change it, upload file, choose your file, double click on it, and you can see the progress here. Now the file is there. You have to press this commit changes so that the firmware.binary file will be uploaded. So finally it has replaced the old file with a new one, right? And this is the original file which I want to update inside ESP32 with the help of Blynk application, right? And you can see the time is now. So just now it has been created, so you can confirm that also, right? Now I'm just going to press upload button from my Blynk application. Okay, just I'm going to open first serial monitor of Arduino. Now I'm pressing firmware update button in Blynk application. So let's press it, and you can see inside this terminal firmware updating message has come, and in the Blynk application also you can find in firmware status firmware updating option is shown. So right now the firmware is being updated from the GitHub to my ESP32. Okay, and you can see in this Blynk application last count is 98. So before the update will be in effect, it will store this 98, the last count, inside non-volatile storage of the flash memory, so that whenever ESP32 will restart after the update, the LED blinking count will be started with the last count, that is 98. So let's wait for some time. You can see OTA success message has come and firmware update successful. Now you can see, okay, so now LED is blinking at half second time. Okay, if you want to change this code, again, if you are sitting anywhere in the world, you just need to change this code as per your requirement. Let's say you want to make it to 1 second delay, and thus you have to go to the sketch option. You have to export to compile binary file, and whatever file that has been generated, you have to replace that file from here, okay, on GitHub. And by pressing this firmware update button, you can change the firmware from anywhere in the world. Okay, so hope you find this project interesting. If you still have any query, just place it in the comment section. Thank you so much for watching this video.